Hello students, welcome to the physics class. Today we will discuss about motion in a plane and we'll start with the concept of scalar and vector. My dear students, you have learned in lower classes about scalars and vectors. Scalars are those physical quantities which are having only magnitude but no particular direction, whereas vectors are those physical quantities which are having magnitude and a particular direction. Now normally for scalars, as we see, for example of scalars like length, mass, time, watt, pressure, these all are the examples of scalar quantities, whereas for vector quantities, velocity, acceleration, momentum, impulse, force, these all are vector quantities. Now addition, subtraction, multiplication or division, this kind of mathematical operations can be done with the scalar quantities by using simple algebra that we normally use. But in case of vector, as magnitude as well as the directions are getting added or subtracted or multiplied or divided, that's why simple algebra cannot be used while using any mathematical operations on vectors. That's why a separate algebra is there for adding, subtracting, multiplying or dividing the vector quantities, and which is known as vector algebra, where with the magnitude the directions are also being operated. So we'll start with the concept of vector. Now why do we need vector? Let's start with the general notation of vector. To start with, a vector quantity is represented by a line, width and arrowhead here. This line, it gives the magnitude, and this arrowhead gives the direction. For example, if we say that a car is moving with a velocity, suppose 10 meters per second, towards east. So how we will explain that, or how we will draw that vector to show that an object moving with the velocity of this towards east. So for that, what we need first is the directions. So as you know, so this point is north, this is south, towards this east, and that side is considered to be west. So towards east. Now if I consider 1 centimeter length to be the velocity of 5 meters per second, then to get 10 meters per second velocity, we need 2 centimeters of length. So suppose this is 2 centimeters of length, for example. So this gives 5 meters per second, this gives 5 meters per second, and is going towards east. So see the direction of east towards east. Now similarly, if I say that an object moving with a velocity of 20 meters per second towards northeast, so the northeast direction is like this, in this direction. So if 1 centimeter represents 5 meters per second velocity, then I need 4 centimeter length. For example, I am telling you to represent, this is though not 4 centimeter, just for explaining I am using this line. So this explains that this is an object moving with a velocity 20 meters per second towards northeast. So this arrowhead, it represents the direction. Similarly, in our direction, suppose an object moving with a velocity of 5 meters per second towards west. So it will be only one part, 1 centimeter of length, which denotes or which represents 5 meters per second velocity. Towards west means towards left. So this is 5 meters per second towards west. So the concept is very important here. How do we use that? Well, now we will discuss about position vectors and displacement vectors. What are those? We'll start with the position vector. So for this, let us consider the position of an object in any Cartesian coordinate plane. Let it be P. Suppose Cartesian coordinate. So suppose this is x-axis and this is y-axis, and this is the position of an object, and this is the origin. What we will do? First we will draw, this is the point P. So we will draw a vector connecting the point O and P and pointing towards P. This is the position vector of point P with respect to the origin. Okay. Now suppose at time t1 the object has moved from origin to P, and let this distance be given as r1. And if I give a vector sign over here, this is the vector sign. So r1 is the position vector of point P. Suppose after time t2, at t2 it is, at t1 it was in P, and at t2 suppose it traveled to Q. So at t2 suppose this point it has come to here. This is Q. So what is the position vector of Q? I have to draw another vector from origin towards the point Q. So this, suppose let it be R2. So R2 is the position vector of the point Q. Okay. Now, how much the body got displaced in the time interval t2 minus t1? How much it got displaced? So this is the displacement of the particle from point P to point Q in the time interval t2 minus t1. So this PQ is actually can be written as OQ minus OP on our vectors. Okay. So the displacement vector we get as, if it is given by R, so R can be written as R2 vector minus R1 vector. This is actually known as displacement vector, and R1, R2 individually they are known as position vectors. Okay. So it is very important to understand the position vector and the displacement vector. The next topic we will discuss about another type of vector which is known as zero vector. Which is written as a zero and a vector sign above. Now what is that? Zero vector. Zero vector is basically, it is, suppose there are two vectors A and B. A vector and another vector B vector. Now if A vector becomes equal with B vector, then what will be the value of A vector minus B vector? It cannot be a scalar, you are using the vector analysis, so that has to be a vector. That's why this is also known as null vector. Okay. Now if an object starts from this point, means initial and final points are same, then what is the displacement vector? What is the value of the displacement vector? That answer is a zero vector. If suppose there are two numbers, lambda and one is mu. So if I multiply a vector A with lambda and add that by multiplying another vector B by mu, what will be its value if A and B are equal and lambda equals to minus mu? If A equals to B and lambda equals to minus mu, what will be the value of this? The answer is a zero vector. So the concept of zero vector is very important in our discussion, though it's not a proper vector, but still it is very important to discuss or to know about the null vector or the zero vector. Few features of null vector. If you multiply any number with null vector, it comes a null vector. If you add a vector with null vector, it comes the same vector. And if you multiply any vector by null vector, it comes a null vector. Okay? Means, for example, suppose if you multiply this 0 with a null vector, with another vector. If you multiply 0 with another vector, the value is null vector. So these are few properties of the null vector system. Next, there is a term called equality of vectors. What is this thing? Suppose there are 4 vectors. 2 vectors are said to be equal only when their magnitudes and direction, not only magnitude, as well as the directions are also same. So if 2 or more vectors having same magnitude and same directions, then those vectors are said to be equal or same. So suppose there are this A vector, another vector, suppose here B vector, another vector suppose here which is C vector, but another vector is here in this direction, which is D vector. See, all of these 4 having same magnitude, length are same, but the value of D, direction of D is opposite. But rest of the 3 are having same direction. So I can write here A vector is equal to B vector is equal to C vector is equal to, if I reverse the direction of any vector, it will become, suppose if this is A, so if I just reverse the direction by keeping the magnitude same, it becomes minus A. Because of the direction. So here, as D is having opposite direction to that, so it will become minus. This is known as equality of vectors. Next, we will discuss about addition of 2 vectors. Suppose there are 2 vectors. Consider, for example, one is this, okay, and another vector is A vector, and another vector is there which is, suppose this, B vectors. These 2 vectors need to be added. Now remember, for addition there is a rule. You can draw either B vector with A vector, or you can draw A vector with B vector, means B plus A or A plus B. But the rule is that first you have to draw a vector A. Directions you see, directions I will not change. But at the end of the A vector, when the A vector ends, from that the B vector you have to draw. Okay? So if you want to add A with B, you have to draw like this. Or if you want to add A with B, means this is B added with A. If you want to add A with B, so the diagram will be like this. First you have to draw B. I am not changing the direction, you have to see this. With that, you have to draw A here. Where B ends, from that you have to draw A. Clear? So what will be the, if I add this, what I will get? How to get this? Now the point I will add here, pointing from A to B. This point, this is known as the resultant, which is given by another vector R. For this is also same from B to A. This is known as R. So this is addition of vectors. Now you can add also parallel anti-parallel vectors. Like for example, suppose a vector is in this direction A. Another vector is in the same direction but small magnitude B. So if you add this, what you will get? A vector plus B vector. Got it? Now suppose there is another vector in this direction A and opposite direction B is there. So I can write this as A vector plus minus B vector. So it comes as A vector minus B vector. So the maximum value that I can get by adding two vectors A and B is A plus B, and the minimum value that I can get by adding two vectors is A minus B. That means, as the minimum value is A minus B, that means that you cannot get a null vector by adding two vectors of same magnitude. I repeat, of different magnitude. You cannot get a null vector, means 0, by adding any two vectors of different magnitude. If A is equal to B, then only you will get the sum as 0. Means if A and this is, if this becomes B, then only if you add A with B you will get 0, because they are of same magnitude. But if B is bit longer, means bigger, then you cannot get 0 by adding them. This is also a property of vector algebra. Now, as my dear students, as you have seen, as I told you, that if you add A and B, as I was showing you, so this is A and this is B, and as you get this as A plus B, okay. Similarly, if you add B and then A, see what you get, B plus A. Now see, suppose this is R and this is R prime. What you can see, R and R prime are both parallel and in the same direction. See, this is the direction of R, this is the direction of R prime. So actually we are getting R equals to R prime. Correct? That means if we add two vectors A and B, A vector and B vector, if we add, we get as B vector plus A vector. This means that this law of vector addition is commutative. The law of vector addition is commutative. Next, you see, if there are more than two vectors, suppose 3, 4, 5 vectors, then how to add that? See, if there are more than two vectors, suppose for example, look here, suppose this is a vector A, okay, another vector is here, suppose this is B, another vector is here, suppose this is C, and suppose another vector is here which is D, and I have to add these four vectors. I have added these four vectors. How to add? The rule is that first I have to take two vectors. If I add any two vectors, I will get a resultant of that. Suppose for example if I add A and B, so I will get a resultant of these two vectors. With the resultant, the third vector C will be added, I will get another resultant, and with the resultant of that I will add G, and I will get the final resultant. So if there are number of vectors, we can add like this. But you remember the rule. Suppose I will be adding A and B, but I cannot add like this because I have to bring the B down where A have ended. So A has ended here, so A is here. Suppose for example, so from here I have to draw B. So the resultant, this is the resultant R. Clear? Okay. Now as I have got the R, so R I have got like this. Now the C is in, so from here C you have to draw. So this is C, so this is R, is A plus B, this is C vector. Then you have to you will get this as, this is the resultant vector of R plus C, means A plus B plus C. Now you have got R prime in this direction, so this is R prime. So with R prime you have to draw T. So from here you have to draw T. Means I will not change the direction, and I will get it as this. This is the resultant of the addition. So what I can write here is like this. Means it's not necessary. So if R equals to, we will get that resultant vector A vector plus B vector plus C vector plus D vector. But it is not necessary that every time I have to add A with B first. I can add A with C. I can add A with D first, then B and then C. Let me show you them. Suppose here, if you see, first I will draw A and C I will add. So first A vector in this direction, this is A, and from that C, so this goes C. See, look at the direction of C, I have drawn like that. So this is A vector, this is C vector. So if you get the resultant, you have to draw like this, okay, and the direction will be in this, opposite to that, okay, and this is the resultant of the first by adding A and C. Then with the resultant R, this is the R I am drawing, suppose I am adding B. So this is the B vector is added. So this is the resultant, means A plus C. Now this is the vector B which is added with the resultant. So what I get? I get the resultant of the two A plus B, A plus C, R means A plus C and B. So A plus C plus B I have got. So now the direction of R prime is in this direction as I have got. Now you have to add D with that. So add D. So as we get, this is R prime, this is D vector. So this you get as, suppose R double prime, that is A plus B plus A plus C plus B plus D. If you remember the previous diagram which I have drawn, both the resultants are in the same direction and same time. That means what we get is actually A vector plus B vector plus C vector plus D vector is equal to A vector plus C vector plus B vector plus D vector. Addition is known as, this law is known as, it is vector addition is associative. First we have seen that vector addition is commutative. Now we see that the vector addition is commutative in nature. I hope this is clear to you. Next we will discuss about the analytical method of vector addition. Two laws we will study. One is known as triangular law and another one is known as parallelogram law. So triangular law of addition of vectors. Now you will understand why we were getting the resultant in the opposite direction. So triangular law of addition says that if two vectors represent two adjacent sides of a triangle, then the third arm is representing the resultant or the result of the sum of the two vectors. If we take two vectors A and B in the same order, means the direction is same, and if it represents two adjacent sides of a triangle, then the third arm of the triangle in opposite order. See, Same order would have been in this direction, but opposite order gives the resultant of these two vectors. Okay, so R is the resultant vector of the two vectors. So we can prove here, we can get also the direction. So how to get direction and what is the magnitude, how to find that? We will do that now. To get the magnitude of the resultant vector and as well as the direction. The direction is found by this angle that this resultant vector makes with A or B. The angle by which we measure the direction. Okay, this is the alpha. So how to prove this? Let us see how to get the resultant value of the magnitude of resultant and direction from by using this vector law, triangular addition law. For this, I have taken a vector here, another vector here, and another vector here. Suppose this is O, this is P, and this is Q. So this is a vector A. So the vector OP is A vector. Vector PQ represents the B vector, which are added to get the resultant vector OQ, which is the resultant R. The result of that vector, addition of the vectors. Now to prove this, what I will do, first I will extend this line and I will draw a perpendicular here and let it be S. QS be the perpendicular drawn over the extended part of OP. Let this angle be theta and this angle be alpha. Well, now triangle OQS. From this what we can write? So we can write OS square plus QS square equals to OQ square. OS square plus QS square equals to OQ square. Now this OS can be written as OP plus PS. OS can be written as OP plus PS whole square plus QS square equals to OQ square. So from this what we get? OP square plus PS square, A plus B whole square formula, plus 2 into OP into PS plus QS square is equals to OQ square. From this, now you see what is PS. Now PS, the value of PS, I can get it from this. Now from this triangle, if I see this PS square plus QS square, PS square plus QS square is equals to PQ square. So in place of QS square and PS square, I will write PQ square. So this equation can be written as OP square plus PQ square plus 2 into OP into PS equals to OQ square. Fine. Now see from this equation, cos theta if I take, what is the value of cos theta from this equation, from this diagram? So base PS by hypotenuse PQ. So from this we are getting PS as PQ cos theta. So in place of PS, I'll put PQ cos theta. Okay. So the equation, this equation we get as OP square plus PQ square plus 2 into OP into, in place of PS as I said, PQ cos of theta is equals to OQ square. We get the equation like this. Now OP equals to, this is A vector, this is B vector, and this is R. So OP means A square plus pq square means p square. I am only taking the magnitude here. I am not taking the direction. I am only calculating the magnitude here. That's why I am not giving the direction here. Okay, vector value. A square plus b square plus 2 OP. OP means A, so 2 into A into PQ means B into cos theta equals to OQ square means R square. So R square we are getting as A square plus B square plus 2AB cos theta. So what is the value of R? What is the value of R then? So the value of the resultant R, magnitude of the resultant is root over A square plus B square plus 2AB cos theta. Okay. And what is the direction? We have got the magnitude of the resultant vector. Now what is the direction of this resultant vector? So the direction, to get the direction, we will do this tan alpha. So tan alpha means, if we take this triangle OQS, tan alpha equals to QS. Now you see, so we are getting tan QS by OS. So QS divided by OS can be written as OP plus PS. So QS equals to, okay, fine. Now you see from this, I will get the value of QS from this triangle. Achha, from this triangle QSP, what is the value of sin theta? Sin theta equals to QS by PQ. Right? So from this, QS equals to PQ sin theta. PQ means P, so it comes as actually P sin theta. And already PS means we have got, PS means, if you remember previously we have got this, PS means PQ cos theta. Matlab PS is PQ means P cos theta. So if I put the value here now, so we get it as tan alpha is equals to QS, which is P sin theta divided by OP plus PS. OP means A and PS means B cos theta. So this gives the direction of the resultant and this gives the magnitude of the resultant. Now depending on the value of theta, the resultant may vary. I will show you in the next discussion. So this is the triangular law of addition of two vectors. Next, law of addition by parallelogram law of addition of vectors. In this case, what it says that if two vectors are representing two sides of a parallelogram, then the diagonal drawn from the same point gives the resultant of the two vectors. Like if there are two vectors, suppose here A and this is B. Suppose this is A, this is B. Drawn from the same point, we are adding. So if we complete a parallelogram with this, then the diagonal of this parallelogram gives the resultant of the two vectors. Okay? So the statement is very important for both the laws. You have to remember. Here also we can get this, that the value of the resultant comes as from triangular law. What we have got, I am just reminding you once more. r equals to a square plus b square plus 2ab cos theta. Okay, and we have got another value tan alpha equals to b sin theta by a plus b cos theta. Okay, so from this, if both the vectors, if the angle, if theta is equals to 0 degree, means they are parallel, if the vectors are parallel, then what is the value of the resultant? R equals to root over a square plus b square plus 2ab. So in place of theta I will put 0 cos 0 degree. So which comes as cos 0 means 1. So a root over a square plus b square plus 2ab, which come as root over a plus b whole square. The value comes as a plus b. This is the maximum value of the resultant. So the resultant is maximum if the vectors are parallel and in the same direction. Okay, that means they are in the same direction, angle 0 degree. But if they are in opposite direction, next if theta is 180 degree, in this case what is the value of tan alpha? Let us calculate this quickly. Tan alpha becomes, so theta I said, theta is 0 degree. So b sin theta, so b sin 0 by a plus b cos 0. So this comes as actually 0. So alpha also comes 0. Means the vectors, the resultant vector is in the same direction with A and B. They are in the same direction. In second case, if theta equals to 180, in this case r equals to, so root over, you write the formula a square plus b square plus 2ab cos 180. What is the value of cos 180 minus 1? So it comes as root over a square plus b square minus 2ab. That is a minus b whole square. It is come a, either a minus b or b minus a, whichever is greater. From that you have to minus that. Okay, and what is the angle then? So tan alpha b sin 180 by a plus b cos 180. I am just putting the value of theta. So this means alpha is 0. So in this case alpha can be either 0 degree or it can be 180 degree. Anti-parallel. Okay? They are anti-parallel. But which one will be greater? Now suppose if A is in this direction, suppose this is A and this is B. So if we do this, B minus A, direction will be, as B is longer than A, bigger than A, so the direction will be towards B. Similarly, if A is bigger, then direction will be towards A. So like this we get. Another condition is there, if theta is 90 degree. What if the two vectors are at right angle to each other? So if theta is 90 degree, value of r is square plus b square plus 2ab cos 90. So this term becomes 0 because cos 90 is 0. So we get as root over b square plus b square. And what is the value of tan alpha? So will come as b sin 90 by a plus b cos 90. So this is 0, but this is 1. So it comes as b by a plus 0, that is b by a. So alpha you get as tan inverse b by a. These are few conditions. Depending, as you can see, depending on the angle of theta, how the resultant is varying from maximum value a plus b to a minus b or b minus a, whatever, and the angles are also, the angle of the resultants are also varying here. Well, this is for the day. I hope you have understand this and you have understood quite well. And in the next class I will discuss about the multiplication of vector and unit vectors till the time, and also the multiplication of vectors is very important there, because we will learn a lot of things there, and especially a dot and cross product, how they are done, what are they exactly. So next day we will definitely discuss that. Till the time, take care and study properly. Thank you.